Welcome back to the Electricians 2 channel. On the bench today, we're going to do a review about this about this TPI Scope Plus 440. We're not going to do a review over the whole meter because I've done a review on this already. I want to focus on this feature that's right here. They say the component test feature. And I've been meaning to do a review on this for a while. I haven't gotten around to it, so tonight I just say, well, I'm just do it. The only two meters that I've seen with this feature is the TPI, and there's a Fluke. It's an older Fluke on the market. I think it's the 867 that has a component test feature along with a logic feature, and this one too has a logic feature. Now, for years, I've been noticing, well, a few years back, that TPI they're sure about their instruments, and TPI they do have some really nice instruments, and they're always going up against Fluke. I mean, openly. I've seen it on, and I'm thinking that this meter right here was a direct competitor against the Fluke 867 or the 867B because all of the features are just about the same. Now, like I say, I don't want to do too much talking. I just want to get into it. Hopefully it won't be a real long video because I just want to see how well this works and explain to you guys how it works. So just give me a minute because I really want to be in depth. I'm going to give me a few minutes because I really want to be in depth about it for you guys who do know about the component test feature. And those who don't, maybe you can learn something and maybe this could be helpful to you, or it may, put it like this, it may or may not be helpful to some of you guys out there. But just give me a few minutes. Let me just tell you what TPI has to say about it. And I'm also going to read what Fluke has to say about their version of this feature on their meter. So without further ado, they say the TPI 440 Scope Plus component test feature lets you analyze components like resistors, capacitors, and semiconductors by generating specific voltage current signatures, essentially creating a fingerprint on the screen, helping you to spot faulty parts by comparing these patterns to known good ones, revealing shorts, opens, or degradation through unique waveform shapes, like a flat line for a resistor or distorted curves for bad caps and diodes. They say the V1 signatures they say the scope applies the voltage and measures the resulting current, okay, through components displaying the relationship as a waveform on the screen. All right, and also it says that you use component tests to measure the characteristics of a passive component in or out of circuit, no power applied. The 440 provides a AC stimulus signal to the component and plots the voltage against the current measurement. The resulting pattern provides information about the passive current circuit condition. And they give you a list of diagrams. This is the one from TPI. They give you a list of the diagrams that you go by. And for what it's saying, what I'm getting out of this, that if it doesn't look like this, it's bad. So basically, this is going to be a quick check of all of these passive components. And right quickly, let me just read what the Fluke has to say about this test also. They say, wow, it's basically the same thing that TPI has. But let me just read from what the Fluke has to say about theirs. Here it is. They say, let me just back up a little. This is from the Fluke. They say, I'm going to pass up all of this. They say the GM displays to the right show this characteristics of some basic components. Testing components in circuit will create troubleshooting patterns that are a combination of these basic patterns. While it is possible to recognize individual component patterns, it is likely that you will need to have a good circuit board available for comparison purposes. This would allow the most efficient use of the component test mode where there are multiple components influencing the pattern. And they also say another capability that can enhance the efficiency of testing circuit boards in the field is the ability to store 3 test patterns in the GMM, and they say waveform storage memory. One storage you can recall a pattern, okay. And the Fluke, it gives you this pattern, this setup. Let me show you. It gives you this one. Now I compared this one to the one that TPI had showed me, and they are compatible if you look at them. This is like this one up here at the top. That's a resistor. So if I were to look at a resistor here, you can find that same, oh shoot. You can find that same, this one right here. That's for this off the Fluke. And this one is off the TPI. You can find that same. So they're basically the same. Okay, and it's just that the TPI has a few more patterns that you can go by. So this is more or less like a quick check. If you were in the field and you were testing something and you don't have everything, to make the test or whatever, you'll make a quick check. This would be a good feature. But let's get right into it, guys. I've talked enough. I just want to show you guys how it works. I hope you guys enjoy the video. If you like the video, just give me a shout out, letting me know where you're watching from, your location, what city, state, town, or country. Just give me a shout out, guys. But here we go. Hit the like button if you like the channel. Subscribe button also. So I'm going to use this test board right here, this circuit board, and the backlight on this TPI is not the best, but I'm going to try to put it where you guys can kind of see it really good at. Okay, let me see. Turn it up. Okay, here we go. So let's start off with some of the resistors. According to I'm going to use the TPI. All right, with a resistor, push this back some. With the resistor, it should either look like this one, depending on like 1 kilo ohm, 0 ohms, and so on and so forth. I'm going to use these blue ones up here. I think that's more or less like it's going to be like a 200 kilo ohm resistor probably. So I'm going to try one of these, and then I'm going to go to the other ones. So let me see. We're going to try that one. And here at the bottom, I know you can't see it, guys. I'm just going to put it in. They want you to use, like say 1 millisecond per division. They want you to use this one. And you want that's the measurement that they want you to use. So let me put it right here. Hopefully you guys can see this. I'm going to use, it's right here where I say 1 millisecond. So that would be 200 kilohertz that is going to be testing as. And as you see, it's 1 millisecond per division, and the slope and everything else is ready to go. So I'm going to do this resistor up here, and we'll see. Sorry about that. We'll see just what happens. All right, hold on a second. Let me latch on to this one, and we'll see. And I think it automatically identifies whatever it is that you're testing, and that's also a good feature. Let me just back up some. So I don't know if you guys can see that. One second. See, if this meter had a white backlight, a white LED backlight, it'd be really nice. But okay, that's the line you see, and it's 1 millisecond, and I'm testing at 200 kilo ohms. So let me just back up. You see the line, how it looks. Let me back up some and show you on here which one that it should be. I'm looking at down here. Okay, so that is a 200 ohm resistor, and that's the one it is. So that's a quick check of that resistor right there. I know you can't see it, guys, from right here. I really want you to, but anyway, that's a quick check. This one right here, and that's the one that you see right here. So now let's do something else. Do another one. I'm gonna do a capacitor right quick and show you guys about this one, about the capacitor. An electrolytic capacitor. I had one. Okay, I do have one. This one is for 65 microfarads, and at 65 microfarads, it should look like, according to this, these are all the capacitors, guys. And how it should look. Oh my goodness, let me see. That's the diodes up here, not the diodes. Electrolytic capacitor, it should be a circle. Electrolytic capacitor, and that's at 33 microfarads. This is 47 microfarads. This is a metal cap capacitor at 22 microfarads, and a mylar capacitor 103, and Tantal capacitor 47 microfarads. So the one I'm about to is an electrolytic capacitor, which will be here, but it's for 65 microfarads, so it may fall. It's a little bit above this one, so it should look sort of like this line right here, straight. So let's just see. Okay, I already have it shorted out. So let's just see what happens. Okay. All right. Now, just back up some. You guys get a good look at this. You see the line? That's it. It's on that side, guys. It's the one that's it's right here with the bullseye, but it's the one right closer to this side right here. That's the line. Let's see if I turn the light on. Press the light on for me. You can see it better. All right, so that'll be capacitor. Let me back up a little bit. That would be right here. Wait. Yeah, it'll be this one. Electrolytic capacitor, that one right there. So, and it's the same measurement. It should be 1 millisecond per division, and at 200 kilo ohms. So that's the quick check. But like I said, they want you to have another meter, another circuit board. It will help to have a good circuit board. If you're out in the field and you testing components on a certain circuit board, it'll be helpful to have another circuit board available that you know that is good, so you can compare to components. So, like I said, there's only two meters that I've seen on the market, and these are old. It's the TPI and the Fluke that has this feature, and I like to play around with it myself, guys. So I'm gonna do one more, and then just to see, maybe one more, and we'll see what it does. Okay, no, not that one. All right, it's the inductor right here. Let's see what happens. All right. Almost. Okay. You see, it's hooked up, and it's giving us a circle. So which one would the circle be? There will be a capacitor too, according to this. Now they say you could get them confused sometime, but I don't see anything else on here that has a circle but that. So that will be a capacitor over there, and that's the circle that it's giving me right here. And I don't, or the mylar capacitor right here, but it looks more like an oval shape. So I'm gonna go with the electrolytic. No, That's not. I think it's this one. My lower capacitor right there, 103. But anyway, that's the features, guys, and I just want to highlight that. I don't want to hold you up, guys. You guys don't forget to leave your location where you're watching from. Help support the channel. Let me know you appreciate the channel. I appreciate you guys. Until next time, you guys take care, and I'm out.